to implement a single disk statically without using any library functions or dynamic navigation. I have statically created a list and should you how it can be created very easily. In this class, we will extend the traffic and we learn how to create a single list dynamically. And this is today's class's agenda. What is list entity and its applications, and how to build a list in C language. And we try to compare array implementation and point implementation of the list, and we see the sample for the whole implemented in C language. Again, refreshing our knowledge that it defines a data structure in a single event, and it tells about the operations supported by the data structure without giving the implementation details. For example, if I say list ADT, list is a data structure which must support insert, search, delete, sort, and print operations. For example, if I say ADT dictionary, in general sense, dictionary means if you take English dictionary, generally in English dictionary, yearly we will add few words and we search for a specific word. So dictionary is a data structure which must support inserting a new element and search for an element. From dictionary generally we never delete any words. So a dictionary is a data structure which supports two basic operations, insert and search. So if I define dictionary editing as editing dictionary, insert insert a new element and search for a reference. Just like that, list is data structure which supports adding an element, searching for an element, deleting an existing element, and sorting the elements in some order, and print all the elements which are there in the list. And a list has lots of applications. For example, if you are implementing a software for a bank needs to maintain its customers' data. Whenever there is a new customer open an account, I need to add the details of customer. If I take the customer as an element, the element includes customer account number, customer name, type of account, etc. So adding adding a new customer comes under inserting a new element into the list and searching whenever if you want to search for a specific account, you can search. For example, the customer came to your bank and asked for his balance. You will ask for his account number. If you enter the account number, the list search and gives you the details of the balance. So search delete whenever the customer closes the account. We close the DVD player, and sometimes it also support update. So, for example, a specific customer has changed his address or mobile number. You need to update. So here I have not included, but update is also another useful operation that was be supported by delete state and sort and update. So if you define list as an entity, it is something like this. And another applications of list are like in a library we need to manage whenever there is a new book I want to add. I should be able to search for a book. I should be able to update the book details. I should be able to delete a book, suppose it is lost. Like that, list is a data structure which is needed by most of the applications. What we most of you take any application, it requires a sort of list. If it is a business application, definitely we need a list. So these are the few applications. Actually, I have mentioned few applications, but we may have lots of applications which requires a list attached. Here I have given very few: phone book, telephone dictionary, telephone directory, library management system, and there are lots of apps out there. If you in your Android phone, you will have your phone book, which is also a kind of list. You are adding a new contact or searching for a contact whenever for a particular contact, if you want to change the mobile number, you are able to change. So you are able to, whenever you want to delete a particular contact, you can delete. So it's a kind of list. So that is the best example of list. So a list can be implemented in two different ways. You can implement the list using an array and using the linked list. As all of you know, if you implement using array, we have some advantages and some disadvantages. For example, the first problem is that you need to specify the size of the array at a very beginning stage. For example, you may think that I have only 100 contacts. So you have created an array of 100 contacts. And let us assume that we have only 55 contacts. So 95 spaces are waste. If you allocate space for 100 contacts, if you use only 5, and spaces to store the contacts are waste. Suppose we have already you have allocated space for 100 contacts, and already you have added contacts, and there is a one more contact. You cannot because its size is fixed. So this is a basic problem of array. Either the space will be wasted or you cannot add the space in runtime. So this is a fundamental problem with the array implementation of this. But advantage, if you look at the advantages, array elements are stored in continuous memory locations. So you can pass you can access the array very fast because they will be continuous memory locations. You can access them very fast. Suppose as they are in continuous memory locations, if you know the size of one element, and if you know the starting address, randomly you can access any element of the same state. That is the advantage of array implementation of a list. And as I have discussed, fast access and no additional space for new elements, and the demand on sheet is static. Okay. So best for fixed number of elements. So you can wherever you have fixed number of elements, you can go for array implementation of arrays, which is very fast. Okay. When it comes to accessing an element, searching for an element, it's really very fast. And linked list, if you go for implementation of a list using linked list, that is using pointers, the main disadvantage of this method is that it's very slow. So if you cannot access the fifth element directly because in a single linked list we store always the starting elements of the first node. If you want to access the values which are there at the fifth node, you need to traverse from first node to fifth node. Then you can access the fifth node information. So with the same speed, we cannot access all the nodes. So access is slow when compared with array implementation application. And we need additional space for pointers. In arrays, we don't require any additional space. You can directly store the elements. But here, in a string, if you create a string in list, we need to have pointers. So we will have nodes. Each node represents an element, and a node requires a pointer to the next node. So additional space is needed. And when if you compare the advantages, list can if you implement the just accepted for random number of elements. That is, we don't know how many elements are there. If there are only five elements, we can create five elements. If there are 100 elements, we can create 100 elements. So it's very hard to do. So in that case, Pinterest is actually very helpful. And the main advantage is that it can grow whenever there are few more elements to be added. Yeah, it's supposed to do it dynamically. That is the main advantage of Pinterest. In C language, we represent a node in a single repetition using a structure like this. Here I have type defined the structure known as node. So whenever I need to create an instance of this structure node, I don't have to type structure node. So it is sufficient to create an instance of the node using simple single node, that is node. So capital N, this is basically type defined. Okay. This is actually type defined new tag. We have created a new tag now. So instead of typing stuck the node, like it's a node. Node is an user dependent data type, just like int. We create an instance of int like this into that, just like we can create an instance of this struct using node. Okay. So it's a separate structure. It has two components. The structure has two components: integer value and a pointer to the next one. So if you create an instance of this, in the memory it is something like this. If you have to see here, this is a node. If you create an instance of node, it is like this in the memory. It will have two compartments. Let us say suppose that I have stored the value 10. So it is something like this. And you see generally pointer occupies 4 bytes of memory. So and integer also occupies 4 bytes of memory. 8 bytes will be added. 8 bytes will be added. And assume that your address is 100. From 100 to byte, this is the 100 to byte. From 100 byte, so you will have 107. That is 8 bytes will be added for this register. Okay. See here, this is actual code. Um, I have included STD or different STD package for functions like Angular, Scala, free, all the dynamic memory allocation functions are there in STD lib in the GCC compiler. So I have included this and I have created the user-defined self-referential structure. As I have discussed in the previous session, self-referential structure with pointer to itself is called self-referential structure. See here, it has a pointer to itself. Structure node star next. Okay, I have created two pointers added there because I want to create a distinct forward direction. So that is something like this. Explore 5 and then 6 and then 7 and then 10 and this is the last one. Okay, this is now. So next, this is the end of this. This is the last one. So I want to create this forward direction. Sometimes people also create a reverse direction. If I insert file it will be inserted, and like this. If I insert 6, it becomes no, it becomes head. Head will be point into this. If I insert 7, head will be updated to 7, and 7 will be point into 6. And if I insert 8, 8 will be point into 7, and head will be point, and the point will be point into 8. So this is called creating a link in a reverse direction. In this example, what I am explaining is how to create a clear increase in forward direction. Okay, see this code. Already we have two global variables. Here I have created two global variables. This is first one and this is second one. Okay. Head and tail. These are two global variables. And I have initialized them to null. It's a continuous code. Okay. See here, this is the function which can insert a new node into this intelligence. I see here I am creating a temporary node temp. It's a temporary node. So for the insert function, we need to pass here I am assuming integer as an element. Okay, that I want to manage. Just like the contacts, phone contacts application, element represents contact details of a person. Just like that here, element is actually integer. For simplicity, I will say element as integer. Now, if we call the insert function with an integer, let us say I want to insert 10 first. Okay. So if you call the function using with the argument 10, what will happen is it creates a node. See here 10 equals to here I am typecasting. I am allocating size of this structure node. Okay, it will be computed as 8 bytes because node has only two components, one integer value and one pointer. So integer and pointer both each are is 1 byte. So 8 bytes are allocated. And another function after allocating 8 bytes, it returns the starting address as void pointer. Because enumerate function is a generic function which can be used to allocate memory for any data. So its prototype will be return type. Its return type will be void star. So void pointer, that is generic pointer. So it allocates 8 bytes and returns the starting address. That I am typecasting into node star. Okay, this is called explicit typecasting. Here node star means pointer to start node. So I am typecasting the void star into node star and storing into them. Now we have allocated space. We have created a node like this, and I have instantiated temp of val equal to x. That is the argument that we pass. So here I have stored temp. And after attaching it to here initially I have stored the argument in this place. Actually I have stored null. Okay. Then it verifies whether head is null or not. See here we have created two variables and initialize it to null. So if you call the function for the first time, now we have head will have null because we have initialized it to null. Okay. So this becomes true if it is first time. Okay, head is null. So if head is null, what I am doing is head equals to tail equals to temp. So this I have created a node whose address is 100. Okay, and here initially instead of 200 there will be null. And I am storing this 100 into both the pointers, head and tail. Okay, we have two pointers, head and tail. In both the pointers, I am simply storing 100. Assume that here Emra has written and 100. We have created a node. So, in the two pointers head and tail, you stored the same value that is 100, and I am returning it. So, as this is first node, we have updated the head and tail both are actually pointing to 100 only, and in this node we have inserted 10 here, and here we have none. Okay, and the function returns. Assume that I have called the same function using 20. Okay, now what I have passed is the value 20 instead of 20. So what will happen? Again, it creates creates a node, temporary node, temp. Okay, and 20 will be stored here in this node in the first variable, that is var 20 will be stored, and the next will be null. Here I am storing null. Assume that we have created the second node, initialize function has returned 200. Okay, so temp is now pointing to 200, and here I have stored 20, and here I have stored null. Okay. Is it head null? No, it's not null. So head is actually having 100, value 100. Head and tail both are having 100 because we have previously inserted 10. Okay, head and tail both the pointers have both the pointers are actually pointing to the first one, that is 100. The first one is 100. Okay, so this is wrong. Head is not equal to null. So what will happen? It will execute this part. This part. So what will happen? Tail of next equals to 10. Okay. Head and tail both are pointing to 100. And here initially we have null. I am replacing that null with 200. Okay. And tail equals to 10. Okay. So now tail will be pointing to this node 200 instead of 100. So tail will move left. Okay. Tail is initially pointing to 100, then pointing to 200. If I insert 300, tail will be pointing to 300. That is hard. Okay. Like that, tail will go this direction. Means the value inside tail will change directions. Okay. So if I call instead of 10, okay, it creates something like this 100 whose value is 100, and here I am storing 10, and here I am putting null. Okay, here I am putting null, and the value of this I am storing into both head and tail. Both are pointing to the same. And whenever there is a new node, I am creating the new node. Okay, 20. And what I am doing is temp of next equals to 200. So what will happen? I am simply overriding this null with the 200. Okay. Now it is pointing to this, and I am making this as a null. Okay. If I insert third node, whose address is 300, now again I am making temp of next equals to 300. Okay, and k equals to 10. So tail will move like this. So tail gets updated. Okay, like this we have created a single definition forward direction. I hope you have understood how to insert a new node. I hope you have understood the function insert, how it is going to create a singly into distinct forward direction. This class, what I am assuming is you have gone through the first video where I have explained self-referential structure, etc. If you have any doubts regarding that, please refer to my first video. And then once again watch this video.